Alright, hello everyone, November 19th. I have a new push. I want to pick up Vim again. I'm starting to cheat my way around, always using the arrow keys. I have to use the, HJKL key to move the cursor around. Yeah, I was doing it today and it was struggle. It was a lot of struggle. I think it will take months at least for me to get used to. And maybe, just maybe, I have to go read the tutorials because I have one downloaded for VS Code. Just have to read that again and then do all the exercises. There's no other way to get you acquainted. And by the way, I kind of thought about this, but have no idea. So maybe I have to go through the hints. I'll come back to this after we finish this, hopefully. Oh, look at this. $3 off. I'm not gonna get this. Minimum amount of time to collect garbage. You're given a zero indexed array of strings garbage, where garbage I represents the assortment of garbage at ith house. Garbage I consists of only the characters M, P, or G, representing 1 unit of metal, paper, and glass. Picking up 1 unit of any type of garbage takes 1 minute. You're also given a zero index array travel, where travel I is the number of minutes needed to go from house I to house I plus 1. Okay, there are 3 garbage trucks. Oh god, we can make this even more complicated. 3 garbage trucks in the city, each responsible for picking up 1 type of garbage. Each garbage truck starts at house 0 and must visit each house in order. However, they do not need to visit every house. So each truck starts 0 and must visit each house in order, but they do not need to visit every house. Only 1 garbage truck may be used at any given moment. While 1 truck is driving or picking up garbage, the other 2 trucks cannot do anything until the minimum number of minutes needed to pick up all the garbage. Alright, that's probably one of the most complex problem. So we have houses, right? We have houses which has garbage, different types, and picking up each takes 1 minute. Going from one to the next takes like 2 minutes, 4 minutes, 3 minutes. And you have 3 trucks, basically 1 for each type of garbage, and they all start from 0, and they must visit in this case, right, in order, but they don't have to stop. They can skip one, like the G can skip this. So we want to return the minimum number of minutes needed to pick up all the garbage. I don't know, so how is this? The paper garbage travel from house 0 to house 1. Collects paper garbage at house 1. Travels from 1 to 2. Collects paper garbage at 2. Done. Altogether take 8 minutes to pick up all the paper garbage. The glass garbage truck collects here as 1. Plus 2, 3, plus 4, that's 7. 8. Huh? Wait, hold on. Again. Paper travels, that's 2, 3, 7, 8. Yes. The glass garbage truck collects the glass here, so that's 1. Travel from 0 to 1. That's 7. Right? Oh, it's glass. That's 8. 8 plus 3 is 11. 12, 13. It takes 13. Huh? I don't understand. Like, you just go through everything. Right? What's so difficult about this? You just go through everything. Try this one. All right, so metal. So have you 3 plus 3 is 6, 7. So 7 minutes, right? For paper, so 3, 4, 14, 15, yeah? For glass, 3, 4, 14, 15. So let's just add them together. But maybe the difficulty is, I don't know, maybe you a timeout. That's because there are a lot of this. I'm pretty sure if you run it 3 times in a timeout. So that is, I think that is the key, right? Because you're gonna go, each time is 10 to the 5th times 10. So yeah, you're gonna time out. So how do we, let's say, run this in one shot? In one shot. Plus, we also need to keep track. Not really keep track, but we can do a list of, oh my goodness, a list of list, an array of array, okay? Array of array to record the count of M, P, and G, right? M, P, and G. And you can go all 3 at the same time. Yeah, you can go all 3 at the same time. And, oh, you do have to go through, ugh. I don't see any other options though. Let's try this. I mean, if it times out, then we figure something else out. All right, no arrow key, okay? No arrow key. So we also done, oh my God. It starts with 0. That's not what we want. Line number, relative, hybrid. Yes, that's the one. All right, so 11K. All right, go to the front. Man, we have to do this. No arrow key is allowed. Okay. It's okay. We can handle this. We can do this. All right. So what's first? First I need to say counts new. That's not right. Maybe this counts. Let's this is 2391. Okay. Okay, M is 0. Why you do it here? Alright, it doesn't make any sense. We shall do it here. How? A map. Okay, so map. Hold a second. Right, let's go up. Up is K. Map integer. No, character. Integer. And map. New hash map. Can we how do we initialize hash map? Java initialize hash map. map of put. Ew, that's ugly as hell. Maybe we can try map off. Map dot off. Yeah. So map off. Oh my goodness. Some things. Okay. M 0. Wait, hold on a second. M what? P, right? P and G. Okay. P 1 G 2. Okay. Now new int. This is going to be garbage dot length. This is going to be 3. Ah, what did you do? I put a P. Undo. Ah. Yeah, it's hard. It's very hard for me at the moment. That's fine. Now we're gonna go through. So for int I go to 0, I smaller than garbage dot length I plus plus. I need to build this thing first. Int j equal to 0, j smaller than garbage I dot length. I have to do this because it doesn't have the other way. Now what we're gonna do is count I garbage I dot chart j. That's not right. Back. We need a map dot get www. Right, so now that plus plus. All right, I think we can delete this. Go to the end. Delete this one. Okay, so we have built our counts, and the answer is an int. Now we're gonna go through the counts. And because one is doing, the other can now go, so what we're gonna do is for int I equal to 0, I smaller than garbage dot length I plus plus. What do we have here? We have to go through the 3 j's, right? For int j equal to 0, j smaller than 3, j plus plus. Oh, we can just add them together, right? Oh, it's just the length. It's just the length. Oh yeah, it's just the length. Okay, hold on. So what I'm saying is, first let me go here, comment out this. We don't need any of this. We don't need this. We don't need this. And I might as well don't need this. Okay. Oh yeah, so what we need to do is First of all, we're gonna do res. Oh, wait, hold a second. It has to go through them anyway, right? Yeah, it has to go through them anyway. So it's just plus equal to the length, and then we will plus. We'll do the travel at the end. We'll do the travel at the end. So we can say plus equal to garbage I dot length, right? And then when it's done, then we can say for int t of travel res plus equal to 3 times t and return res. I'm not sure. This looks awfully just weird. I'm not sure. Is this right? Okay. Go to the front. Go to the front. This man just didn't do anything. It's not right. One, 2, 4, 6. Oh, some truck might not need to do. Oh, that is, huh. I see. I see. Some does not need to keep travel. Yep. Like metal truck doesn't need this, so interesting. Well, I mean, this is right. You have to do this no matter what. But then you need to know what is the longest. So you go from this, right? See who's in there. How can we do it faster? Like in this case, M only need to go here. The first time it appears. First time it appears. Exactly. That's what we need. First time it appears. First time it appears. So do we do a prefix sum for the travel? Not as we can. We can do a prefix sum, and then we go from right to left, and find the first one. Then we can get its time. Maybe we can do that, or we go. Yep, I think that's a good idea. How do we go with the front? Go down. Delete everything. Okay. We need a prefix sum here. So int pre-sum equal to new int a garbage dot length. Right, and then we say for int I equal to 1, I smaller than garbage dot length, I plus plus, and pre-sum I will equal to pre-sum I minus 1 plus travel I minus 1. Okay, then what we need is we delete this for int I equal to garbage dot length minus 1, I large equal to 0, I minus minus. Okay. So how do we know they all three has been checked? So we checked first. Oh, check number num checked int. You might have to go all the way down, right? So checked 0, right? So we can say I large equal to 0 and checked is smaller than 3, right? And we say if garbage I dot contains char sequence Java character char in string index of oh. Okay, we'll do index of. So here it shall be index of. Now we'll do m. Oh, checked. Okay, that's not the right way to go, right? Okay, so we also need checked okay, total checked. Okay, we can go total checked. Okay, so we can find the next checked, call it total checked, and then if index of m, we go first check is if checked m, I just go 0. If checked 0 is equal to 0 and it contains, what do? We need to do two things. So we need this. We need to do two things. Oh my god, index of. What does index of give you? I think larger than 0, right? Minus 1, yeah, so it's larger than 0. Large equal to 0. Then we say checked 0 will go to 1, and the rest are plus equal to pre-sum I. And total checked plus plus. Or maybe I can just say checked 1 plus. Yeah, that's fine. Else if checked 0, checked 1. Oh my goodness, we have to do it 3 times. No, we can definitely don't do it so many times. Oh, It's tough, very tough for me at the moment to really to bring everything together. So I need to select it, right? Select, find this, and then delete. Okay, so no, we won't go up. We should say for int j is equal to 0, j is smaller than 3, j plus plus. Oh, then we need to indicate which one's which. Damn. All right. Trucks. No, that's not what we want. Undo. Go up. String. Trucks is mpg. And that's a gun. Right, and then we go to the end. We do this. We'll go down. No, go down to the front. Go down. We'll select this D. Go up P. Right, and go up. Go for find 0. And this shall be J. Right, if this is equal to 0, and we need to go to find this, do ca this and trucks.get not char at j, right? And then checked, so we go down, go to 0, change it to j, and then and then for the next one, and then it will go, and then it will be done. All right, so what is this? For loop can be replaced with enhanced for. That is correct. So let's replace with enhanced for. All right, so let's go 7k. Go to the front. Okay, let's try again. I mean, it's not hard. It's the majority of my thought process is really in the trying to get the IDE to work. Not really IDE to work. Try to get my Vim, shortcuts to work. Really, I mean, a month. I give myself a month. We go 4j. Very straightforward solution. No trick, no DP. Since each garbage must be picked up, the time for picking up all the garbage is the sum of the string length in the garbage array. Then we need to figure out the number of stops each truck must travel. Right, must travel. A truck only needs to travel as far as the last house that has its designated garbage. Thus, we can iterate from right to left on garbage and designate the first encounter of a garbage type as the last house that its corresponding truck must arrive. We can use a prefix sum, prefix sum array to quickly obtain the amount of traveling time for the truck. Albeit on times, we call it on because this is 10. Oh, we can say on times 10 times 3. Sorry, this is on times 3 times 10. Okay. I do feel that the K and J is getting a little bit better. Let's go to the solution. Hash map. Okay. In place modification. I don't like in place modification. Oh. Prefix sum. Garbage type. Do this plus equal to. Alright, doesn't matter. Alright, now we have to go back to this, our great struggle. Where's struggle? I remember this one. Anyway, so this is a 2D, right? It's a 2D problem. So I was thinking, okay, what if this is a 1D problem? It's like a range, right? You're given a range. So let's say if we only have 1D, right? We have 1D. We have 1, 2, 3, 4, 1D, and then there's like X, and then we have the query is 4, 1, and 2, and each one is just associated with a value. So this one associated with the value is 10. This one associated value is 7. This one associated value is 7, and this one associated value is 6, right? And then we can do a suffix max, right? So a suffix max will be 6, 7, 7, and 10, right? From this way here. Then for 4, your binary search, and then you pick this value, right? For 1, your binary search, you pick this value. For 2, your binary search, you pick this value. Done, right? So for a 1D, so a 1D problem could be sort suffix sum and binary search. So that's 1D. It's easy to solve. But the problem now is it's 2D, okay? Which means we can do this, but there are two queries. So it's hard because when we can do one query, right, with binary search, okay? This one is okay, but this is 1, right? And we have the nums 2, right? The nums 2. So if let's say nums 1, we say x is 1, 2, 3, 4, but y is different, right? Y for 1 is going to be 9, and this is going to be 5, 4, and 2, right? So the query The first query is easy. So second query. So first query 4 and 1. This is easy to solve because 4 is already at the end. There's no way you can just go straight ahead. But the second query is tough, right? 1, 3. You get 1. Then you need to find something larger than 3, but you can't. You have to loop through this whole thing. Yeah, it doesn't work. So that's where we got stuck yesterday, and I honestly have no idea. So let's get a little hint. Let's start from a little topic. Binary search stack. Ugh. I was dreading. It's gonna be segment tree. No, please don't. If I can avoid segment tree, I'll avoid it. I do not like segment tree. If it's segment tree, I will Python it. I'm not gonna do Java on segment tree. But also monotonic stack. Monotonic stack is interesting. Monotonic stack. All right, let's see the hint. Sort tuples and a query by x coordinate descending. And query by x coordinate descending. Yeah, I think the query is interesting. You have to query in a certain way. So you're telling me that we need to query it differently. So, okay, that's fine. So we query by what? We'll query by 1, 3 first, and then 2, 5, and then 4, 1. Okay? So we say we'll query by x coordinate descending. That's fine. But how do we handle the y? That's the thing. Or maybe we don't need to handle the y. Maybe we can, I don't know. Because what we want to find, right, is a bigger, right? The bigger value. The max. We might have just to look through all the hints. Before answering query, add all xy pairs with x larger equal to min to some data structure. Add all xy pair to some data structure. Use a monotonic descending map. Monotonic descending map to store y x plus y pairs has descending keys and descending values. When inserting a pair, remove all pairs. Oh, are you telling me to keep it sorted? When inserting a pair, y and x plus y, remove all pairs y prime, x prime, with y prime smaller and x prime. No, that's a monotonic decreasing stuff. Remove, no, it's oh, wait. It says a monotonic map has ascending keys and descending values, when inserting a pair, y and x plus y, remove all pairs with y prime smaller than that, and huh? You say you want ascending. And you'll remove y prime smaller than y and the y x plus y prime smaller than that. I don't understand this. What's the next hint? Wait. Let's go back. So we sort this. Okay, so we sort this. This is a y. X plus y is 10, 7, 7, and 6. It's telling me a map has ascending key. That'll be 2, 6, 4, 7, 5, 7, and 9, 10. And when inserting a new pair, remove all the pairs that is smaller. So we make sure it's monotonic increasing. No, it's monotonic decreasing. Huh? So if current is smaller, then we keep it. If current is bigger, then we pop this. remove all pairs with y prime smaller to y. So it's a decreasing, right? So if you have something that's smaller than the new one, then maybe it's increasing, so we pop it, right? And it has to be y is smaller and x plus y. So what we pop out, so if we have something big comes in, so they will all get popped out. Because what you want is if we have some y is huge, right, which makes its value huge, so that will always appear at the end. And but it's decreasing, so if its x is small, so that thing will come up early. Hold on, I think it does make sense. So I sort by x first, okay? I sort by x, so I have the initial order, right? And then this is the order I'm going to create the monotonic decreasing array for y and x plus y. So this is the order I'm going to insert. So every time I insert y and x plus y, the next time I want to insert a new one, we call it y prime and x prime plus y prime. Then we see if this and this, then we insert. What if it's equal? Well, once you join it, if this is and this, then we push it in, which is exactly the situation, right? Because x is going up. So if y is smaller, then this definitely is smaller, right? That means they're in order. So if we find some x, right, we find a position of x, doesn't matter, we are going for position of y, right? For position of y. But what if the position of x doesn't work? Yeah, x is going up, right? So we add this. So when we query, we only query based on y. Okay, we query based on y. What if I have a giant, x, right? What if I query 5 and 2? If I query 5 and 2, you say I query by 2 and I find it's going to be here. But larger than 5 it doesn't exist, so this shall be -1. Right? It doesn't make sense. Yeah, I have Python this thing. Doesn't matter. I just want to try. Five and 2. Yeah, should be -1. Well, I mean, that is a special case because 5 is larger than 4. If we have anything smaller, So basically, x is increasing, y is decreasing. And if we have something that's, small, and we just ignore it, right? And we just ignore it. And then if we have a y value and an x value, so if we have a y value somewhere, an x value is there, how are we gonna do? Like a bigger x value and a small y value. Wait, hold on. The big x value and a small y value, they are going to the same direction. So we want a small x value and a small y value, right? A small x value going to be the front, and a small y value. So y value will be overriding the x. Because a small y value, we need to find the y value, right? Where the y value is. And the x doesn't really matter because x will be pointing to a bigger one. So that will work. Okay. So how about a big x value and a big y value? Okay. So a big y value we're pushing here. That is the problem. A big y value, let's say 9. And also a big x value, let's say 4. Right? 9 and 4. So when that happens, they're mismatching. If we match by that, so yeah, 9 should also be -1. Yeah, 4 9 is also -1. How'd you figure that? You cannot do 2 binary search. Don't think it will work. Well, I mean, if you do it this way, you will have a sorted x, albeit some of those will be omitted. Right? Some of those will be omitted. And you have a sorted y. Some of them will be omitted as well. And if you binary search, then they have a mismatch. Then we say it's bad. If y is the same, then x plus y will be big. Then we need to pop the previous one because we want the bigger one. Yeah, y is the same, then we have a bigger option, right? So we want a big one to remain. And if y is the same, right? Y is the same, then we will compare. If we'll have a bigger x plus y, then previous will be popped. Okay? That's if y is the same. And you will only have bigger, you won't have smaller if y is the same. So if y is bigger, right? If y is bigger, then x plus y would definitely be bigger, so you will definitely pop. You'll definitely pop. So you end up with a y that is, from big to small, to small, to small, it will gradually go small. And then this monotonic, the y is going down, x is going up, the total is going down, right? The total is going down. And we will query based on y. Okay? We'll query based on y. Maybe we should query based on x as well. Right? We'll query based on both y and x. And if they land at the same spot, what does it mean for x to land at a spot? Well, we want bigger, so yeah, those are x are bigger. And we want y also bigger. Those are the bigger ones. So what you're saying is make x go this way, make y go this way. Therefore, if we get an x match at a certain point and get a y match at a certain point, because y cannot match down, x cannot match earlier, so they have to be at the same spot to say, okay, we can find something that satisfies both. And then we also have x plus y is going this way, right? Going down, which means this is the max x plus y you can get. You can go lower, you cannot move further, because if you move further, y may be smaller, right? So the y equal or have to take the one on the left. X equal or now I have to take the one on the right. But still, why would it work? I don't even know. I don't know if it works. It's strange. Why would it work? I mean, the main thing is we're popping some stuff. Why can we pop some stuff? I mean, the stuff we pop is a smaller y, right? A smaller y that causes x plus y to be smaller. Those we pop, right? But it's the new one comes in. The previous one is small. Okay, so we pop it. Why do we do that? Or why? Yeah, the thing is the y can be bigger. My y can be bigger than you. Yeah, if the current y is bigger than the previous y, then your x plus y will definitely be bigger than the previous x plus y. So you would just get popped. No question. But why can we pop? Because we want the bigger one, right? Which means if we match to the one that gets gonna get popped, it'll be okay, right? Because we're gonna match. Mm. All right, I have to keep thinking about this. I don't know. It's I read a hint, but still, no idea. I mean, I kind of know how it's done, but I couldn't convince myself at the moment. I could not convince myself. Feels very arbitrary. Anyway, I'll see you guys tomorrow.